Hello and welcome to the Chanda Academy. In today's video, we are going to learn how to calculate a scalar product between two vectors here in R3 using their coordinates. So first, let's define two vectors x and y by their three coordinates, which are real numbers. Then I'm going to show you how to calculate a scalar product between two vectors. A scalar product between two vectors x and y can be written with a dot. We also call it the dot product, but also in this form. This form here will be a lot used in physics and in high school, and this form will be far more used in mathematics when you arrive at university. Here, because you are in high school, we are going to use this form. So here, because I am in mathematics, I don't have to put an arrow on x and y because I said that they are in R3. So the scalar product between x and y, so let's call it capital A. If I rewrite x and y as their coordinates, x1, x2, x3, scalar product dot product y1, y2, y3. So how do I do this scalar product? As I said, this is a scalar product. So the result we are going to have will be a scalar, which is another word for, at your level, a real number. Okay, so the result will be a number, not a vector. Okay, this is not in R3, this will be in R here. So how do I do it? I just multiply each coordinate between each other, so here times, and I add it to the product of the two second coordinates, and I add it to the product of the two third coordinates. So this gives me x1, y1 plus x2, y2 plus x3, y3. And here I see that I have multiplication between real numbers, multiplication and additions between real numbers, so the result will be a real number. Okay, so y2. So this thing belongs to R. This is a real number. And here we have the formula for the scalar product of a vector of R3, sorry. So now let's apply this to the vector A, to the scalar product A is equal to the scalar product of 1, 2, 3, and 1 minus 1, 2. So as I said, I just have to multiply each coordinate between each other. So this gives me, for this one, 1 times 1 plus 2 times minus 1 plus 3 times 2. That gives me 1 minus 2 plus 6. Okay, and this gives us 5. So A is equal to 5. An important thing you need to know is that for any vectors, so if my vector is of type n, okay, so I have x1, x2 until xn, and another vector, so this is scalar product, and another vector y1, y2 until yn, okay, the scalar product will still be defined as x1, y1 plus x2, y2 plus, it's always the same thing until xn, yn. So this is the definition of the scalar product using the coordinates. We will see in another exercise that in geometry, so in geometry, okay, the scalar product can be defined y times x times y, okay, can be defined as the norm of x times the norm of y times the cosinus of the angle between both. Okay, but this is for another exercise. Hope you enjoyed the video. See you soon. Bye.